Alrighty, if you are joining us from Miss Renee's class, welcome. You will be working on the same assignment as we are, like we do every day. And just like Miss Renee's room, I'm going to ask that if I am writing, you are writing. So we will be working on a seesaw activity today. All right, your seesaw activity has not unlocked to you yet, so no worries. I'm going to share my screen so that we can review the success criteria that you are going to be going over today. We are moving back into fractions. We took a break from fractions to look at money and counting coins and bills. On Friday, you put a nice little bow on that with your assessment, and we're going to go back in to complete our fraction sections. The comparison lessons that you did with money are going to help you with these fraction standards because you are also going to be comparing fractions and determining if fractions are larger or smaller than another fraction that is shown. So you will be working today on this highlighted section of 3-2. Compare two fractions with the same denominator by reasoning about their size based on the same whole. Okay, so we're going to be looking at fractions that have the same denominator. First things first, there are some important pieces of information for us to think about before we start comparing fractions, and Miss Renee is going to share those important pieces of information. I will be sending you into a breakout room to discuss the vocabulary that you heard. So please listen and think about the math vocabulary that is going to be helpful for you with this standard. Aiden Hampton, a question about math before we begin?
I don't know what we're doing because I just got here.
Welcome. We are getting ready to watch an example video about our math. There is nothing for you to be working on right now. All righty. All right, here we go.
Today we are going to compare two fractions with the same denominator by reasoning about their size based on the same whole. To compare, we will use two fractions with the same denominator. To compare fractions, we will also use our comparison symbols like greater than, less than, and equal to. Take a look at these two cookies. It says to compare 1/2 and 1/2. Let's imagine that these two cookies are in the classroom and the teacher says that we can partition them into 1/2s to share equally. Is it fair that the students on the left get a smaller cookie than the students on the right? Why not?
All right, so let's talk about it. Is this fair that you would get a half of the cookie on the right and your friend would get a half of the cookie on the left? Is that fair? Why or why not? I'm going to send you into some breakout rooms to have that conversation. When you get back, you will share out. Is it fair? Why or why not? Bye. Need to share. So let's hear from Aiden G. Is it fair that one would get this half when another would get this half?
No.
Why?
Because it's right. Because if you get 1/2 of the big cookie and the other person gets the other half of the small cookie, and you combine them together, and you can make it equal. So it's equal parts.
Okay, so the fraction of 1/2 is equal. This is a half, this is a half. That's the same fraction. Are these the same size, Aiden G? Are these the same size halves? So if I were to give myself, I can't draw on it, were to give myself this piece, and I were to give you this piece, would you be happy?
No.
Why not?
Because you have the bigger piece and I have the smaller piece.
I got more dessert than you. Okay, so no, this is not fair. This is not equal because the whole is not the same size. Okay, so just because we have the same fraction word, half, doesn't mean that it's the same equal sized piece. Okay, half of a giant cookie is not the same as half of a bite-sized cookie. Okay, those are different.
Receiving 1/2. But we know that the cookie on the left is much smaller than the cookie on the right. When we compare fractions, we have to compare fractions that have the same size whole. When fractions are modeled with the same size whole, it is a fair comparison. Let's do an example together. Here we have two models to represent the two fractions we are going to show today. I notice that both models are equal in size. They are the same size whole. This will be a fair comparison. Today we are focused on comparing fractions with the same denominator. I notice the denominator is 6. So each model is partitioned into 6 equal parts. Each part of one whole is the unit fraction. We call this 1/6. I have now labeled all of the parts in both of my models with the unit fraction. This will help me as I compare fractions today. On the left, we have 2 1/6. We know that's the same thing as 1/6 plus 1/6. So I can take my highlight tool and I can shade in 1/6 and another 1/6. On the right, we are asked to represent 4 1/6. That's the same thing as 1/6 plus 1/6 plus 1/6 plus 1/6. On the right model, I can shade in 1/6, 2/6, 3/6, 4 1/6. So today we're comparing these two fractions to see which is greater, which is less. I notice that on the left model, I only have 2 parts that are shaded in and only 2 unit fractions being added. On the right model, I count 4 parts that are shaded blue, and I see 4 unit fractions that are being added together. This tells me that 4 1/6 has a greater area, that it is the greater fraction. So now I need to pick my symbol. If 4/6 is greater, I know that I put the open part of the symbol towards the greater number. We can read this from left to right, saying 2/6 is less than 4/6.
Okay, so comparing fractions that have the same denominator is what we're going to take a look at today. First, we're going to take a look at shapes which have been partitioned equally. So I'm going to ask you right now to go to your seesaw. And if you have not already, click on your activities to refresh your feed. And you will see the activity, Introduction to Comparing Fractions, at the top of your activities. This says that with your teacher, you're going to complete slides 2 through 9. That's what we're going to work on together today. And then you're going to have some time to work on slides 10 through 16 to compare fractions as well. Go ahead and click on that Add Response button, and that will open up today's work. Again, if I am writing something, I'm going to ask that you write the same thing so that you're kind of taking notes as we work. Slide 1 is our success criteria that we've already reviewed. You can skip past that. Slide 2 is a link to the video that we just watched together. If you're working independently and need to see this again, you can click on this link anytime. Slides 3 and 4 are the visuals that Ms. Renelle shared in the video, reminding you that the whole must be the same size in order for the fraction to be equal, okay? 1/2 of a smaller object is not the same as 1/2 of a larger object, even though they're both 1/2. The size would be different. Slide 5 is where we are going to work today. It says with your teacher right here. So please go to slide 5. And we're going to compare these two fractions that we've been given by completing the models. Okay? I like to shade with the highlighter tool. So I'm going to grab the highlighter and make it my favorite colors. Feel free to do the same. And I notice that this model has 8 pieces because my denominator is 8. It is asking me to shade 2 of the 8 pieces. I'd like for you to shade 2 of the 8 pieces. I'd also like for you to make sure that the 2 pieces you shade are right next to each other. I don't care if you do the same pieces as me, but please make sure that your 2 pieces are touching. And I'll tell you why that's important in a moment. So you want your 2 pieces to be touching. Okay. So this model now shows that we have 2/8. Now I'm going to come over to this model, which asks me to shade 6/8. I'm going to start shading in the same place that I shaded the 2/8. I shaded this piece first. And the reason that I'm going to do that is because sometimes when we start in different areas, it's harder for our brain to imagine which is larger or smaller. So I like to start in the same place so that my mind's eye, my brain imagination, can see the shape of, or the size of the shapes when they're right next to each other. So there's 4 pieces, there's 5 pieces, there are 6 pieces. And again, I made sure my pieces were touching. I don't want to shade one here and then skip, because when the pieces are together, it's easier for me to see which is larger or smaller. If I have blank spaces or white parts in between, I have to move them in my brain and imagine, and that can be a lot. So I make sure that my pieces are touching, okay? If I were to trace the outside, 2/8 would have that much space. Look how much goes around the circle with 6/8. Man, that's a much larger piece over here on 6/8. So my comparison symbol is going to say that 2/8 is less than 6/8. So my comparison symbol, or my alligator mouth, as some of you have come to know, is going to be open or eating the 6/8. That is the bigger piece, so that's what it wants to chomp on. There's my alligator. Okay. What questions can I answer about why 2/8 is less than 6/8? Questions, concerns, or comments? Feeling good? Okay. So this is how we compare fractions when they are part of a shape. Up next, we're going to look at how to compare fractions when they're on a number line. So Ms. Renelle will show us an example, and then we'll work on one together, okay? So this is comparing fractions as a shape. This is comparing fractions as a number line. I'm going to click on the video and play it on my end. You don't need to click on the video on your screen, because then you'll hear both sounds at the same time, and that's confusing. So I will play the video for everyone.
Another way that we can compare fractions with the same denominator is by using the number line model to represent our work. The top model is highlighted in yellow. The yellow number line is representing 5/8. I notice that it is partitioned into 8 equal parts. And then 5/8 or 5/1/8 is marked or plotted on the 5th 1/8. If we start at 0, we can count the spaces. 1/8, 1/8, 1/8, 1/8, 1/8. We have done 5 jumps, which means we're landing on 5/1/8. Next, we can look at the green number line. The green number line is also partitioned into 8 equal parts because our denominator is 8. Starting at 0, we can count the spaces. 1/8, 1/8, 1/8, 1/8. How many jumps did we make? 1, 2, 3, 4. We have now plotted 4/1/8 or 4/8. Let's talk about which fraction has more area or more unit fractions highlighted. So our yellow model shows 5 out of 8 unit fractions. Our green model shows 4 out of 8 unit fractions. So which one has more space? I can see that the yellow model is closer to the 1 whole. So 5/1/8 is greater than 4/1/8.
Okay, so our number line, when we're looking, we're going to see which section is longer, which section is closer to the 1 whole, and that's going to be the larger there. Okay, I'm going to ask that you go to slide 7. This again says with your teacher, so you're going to complete this with me, your teacher. Okay, my number line is blank. I also don't have numerical fractions down here, so I have to look at my words. Third. I am working with thirds. Okay, so we're going to divide or partition these number lines into thirds. Here's what I'm going to ask you to do. On your shapes tool, grab this blue subtraction sign, and we're going to turn it up and down, and we're going to shrink it. And that's going to be the division lines or the partitions on our number line. Okay, so go ahead and grab that shapes tool. It looks like the blue subtraction symbol. And then turn it on its side and shrink it. This way we can duplicate the line that we need, and we don't have to use the drawing tool to erase our mistakes. All we have to do is slide this where we want it to be. Okay, I need to make thirds, and with one line I have half, 1 piece, 2 piece. So I need to make another line, so I'm going to duplicate that. And then I'm going to drag these until I feel like they're at about 1/3. So until I feel that I have 3 equal size spaces. That looks pretty good to me. Go ahead and do the same. So I imagine where my half is, and I put it to the left and I put it to the right. And that's going to create my 3 spaces. Then I'm going to do the same thing on the bottom. I'm going to duplicate that line and drag it straight down. Because both number lines show me thirds, I don't have to do anything different. I'm going to pause there. I can see that a lot of you are working on that. If you want to see it again, I went here to the shapes, clicked on that subtraction sign. It's way too big and it's sideways, so I turned it and shrunk it. Okay, I'll give you a moment to get that done and create your thirds. So now that you have created your thirds, we're going to label them just like we would on a standard number line. So I have, there we go, 0 thirds. Remember, if I'm writing, you are writing. 1 third. 2 thirds. And 3 thirds. I'm going to do the same thing for my bottom number line because both of my number lines are dealing with thirds, okay? So I have, again, 0 thirds, 1 third, 2 thirds, and 3 thirds, which we know is the same as 1 whole, okay? My directions ask me to compare 1 third and 3 thirds. So I see 1 third is after 1 space and it's right here. So I'm going to put a big fat dot or a plot right there on 1 third. Please do the same on your screen. My next one asks me for 3 thirds. So I need 3 1 third pieces. That's all the way down here at 1 whole. So again, I'm going to put a big fat dot or a plot point on 3 thirds. Now I can write my fraction comparison. I am comparing 1 third to 3 thirds. When I look, I can see that my purple number line all the way over here is longer than my pink number line placement. So 3 thirds is larger. So this would read 1 third is less than 3 thirds. Are there questions about why that is true? Any questions? Okay. We are asked down here to use the typing or microphone to explain how you know. You can't use the microphone if you are on Zoom because you'll hear me. So let's all use the typing tool and we are going to explain how we know. So we know because 3 thirds is the longer place on a number line. 3 thirds is the longer place on a number line. So again, we're using math vocabulary. I'm using the fraction, I'm using place, and I'm using number line. I'm not just saying because it's bigger. Okay, that doesn't tell me which one is bigger. It doesn't tell me that you understand bigger is going to be greater. So we got to use that math vocabulary. Okay. 3 thirds is the longer place on a number line. You might also say 3 thirds is longer than 1 third. Oh, excuse me.
Miss Husa,
Yes, Terrence.
you can't record because all you have to do is turn the computer down.
Oh, well, you could do that, yes. All right. So we have looked at how to compare shapes. We have looked at how to compare number lines. Next, we're going to take a look at how to compare sets. So remember, a set in a fraction is like if you had a bag of Skittles and you wanted to see how many were blue, how many were purple, how many were yellow. That's a set. It's multiple objects inside of one group, okay? So we're going to look at a set next. Again, this is a video on slide 8. I'm going to play the video for everyone. You don't need to play the video unless it's work time and you need to see it again. Okay, so I will click play on slide 8 and then we will work on slide 9 and be done. Okay, so this is how you compare fractions of a set.
When we compare fractions with the same denominator, we want to make sure that we are representing the fractions using two models that are the same size. It's very important that your whole is equal to each other. So take a look at this example. Our job is to compare 5/8 and 3/8. Notice that my models are exactly the same size. That means we can compare these two fractions because each part, each heart, is the same size in both models. So let's take a look at how we do this. Compare 5/1/8 and 3/1/8. On the left side, I notice that we have 5 black hearts. 1, 2, 3, 4, 5 hearts. 5 out of 8 hearts have been shaded. We have now represented 5/1/8 because we have counted 5 of the unit fractions. On the right side, only 3 hearts have been shaded black. 1, 2, 3. We have represented 3/1/8 because 3 out of 8 equal parts is shown. Now we can compare using greater than, less than, or equal to. Look again at our models. Which model shows more unit fractions or more parts shaded black? That's right. I notice that the left model has more hearts that have been counted. So, how do I know? I know that 5/8 is greater than 3/8 because there are 5 parts shaded. 1, 2, 3, 4, 5. And on the right, there's only 3 shaded. 1, 2, 3. Make sure today, when you are comparing fractions, you take time to explain how you know which fraction shows more.
All right, so we're going to take time to do exactly that. We're going to explain how we know. Slide 9 is the final slide that we'll be working on together. Please go to slide 9. This is a set. This is a set of unifix cubes or counting squares that you might have been familiar with at Indian Creek in 1st and 2nd grade. Okay. We see that we have a set of 6, which is why our denominator is identified as 6. We are asked to compare 2/6 and 5/6. Okay. So on our left side, let's go ahead and shade 2/6. So I'm going to choose 2 of my fraction pieces, my unit fractions, to shade. And again, I'm going to shade 2 that are right next to each other. It's a lot easier for my brain to decide which model has more when I don't have to move them around in my head because there's blank spaces. So this is 2/6. On the right, I've been asked to shade 5/6. So I'm going to again choose 5 that are right next to each other. 2, and if I'm shading, you are shading. 3. I've done all of the top rows, so I'm going to add 2 more. There's 4, 6. And finally 5, 6. So now I have 5, 6. I've been asked to compare them. So when I look at these, I can see that there are more blue pieces than there are red pieces. So my comparison symbol will be open toward the larger fraction, which is 5, 6. Again, we've been asked to explain how we know, and we're going to explain how we know using math vocabulary. We're not just going to say it's bigger. That doesn't tell us which piece is, and that doesn't tell us why it's greater, okay? So I'm going to get a text box. I'll invite you to do the same thing. I'm going to move my text box down here so that it's long enough to record my writing. And I will put 5, 6 has more shaded parts than 4, 6. That's how I know that 5, 6 is greater than 2, 6. Yes, thank you. You're really choppy. Try it one more time for me, kiddo. Thank you. I'm going to ask you to put it in the chat, and then I can help you there. So I'm going to ask you here. And let's see if I can answer your question. I think I just heard it come through. On the left, there are only 2 pieces shaded, and on the right, there are 5. That would work as an explanation as well. Yes, because you're using that math vocabulary of the numerator, 2 and 5, and you're also using that math vocabulary of parts or unit fractions. So that is fine as well. Okay, if that was your question, I hope that's what I heard. If not, correct me in the chat. Okay. All right. Today, you are going to independently complete 2 of each of these. 2 shapes that you're comparing, 2 number lines that you're comparing, and 2 sets that you are comparing. Okay? You will do exactly as we did. You will label the unit fractions, shade the model to represent each fraction, and compare using greater than, less than, or equal to. You will also type or voice record how you know your answer is correct. Okay? That is your assignment for today.